Again, today this video focuses on CDU management for liquid-cooled rack and liquid-cooled data center. The previous videos we focused on really talking about how you are able to collect IP collateral from a server itself through server management, and also focused on PDU management of collecting sensor data and also lifecycle management for a PDU. So today we're going to focus on CDU management. So as I talked about in the previous video clip when I kicked this off in regards to the series of podcasts on managing and monitoring Blackwell Compute, focused on of CDU management and why that's become vital for liquid cooled data center. So you can think of the CDU itself as really the heart that pumps basically water through the veins of the entire server itself, right? And providing that level of liquid cooling for a specific server, whether it be at the compute or whether it be at the GPU itself. And so part of this solution for liquid cooled data centers are two use cases. One being in-rack CDU, which we're going to talk in detail in this video clip, which really is the CDU that's in the rack slot unit 1. We exposed or showed you that information in pod view. So now we're going to drill down and look at very important aspects of lifecycle management for the CDU. And this is the in-rack CDU I'm talking about as far as collecting analytics, showing you from a Blackwell chipset how we basically do leak prevention or leak detection and the enforcement policies that we focus on for that use case. And then we'll get into, in another video clip, the in-row CDU option, which sits in a centralized cabinet at the beginning of the row of racks that are essentially controlled by this in-row CDU and provides scalability to support liquid cooling for 10 racks itself and be able to scale across a megapod or also superpod within your AI factory. So what you're seeing in this particular view of SuperCloud Composer, we've actually launched the cooling infrastructure support for SuperCloud Composer and how it provides a complete turnkey solution. If you're looking at specific cooling from our turnkey solution, whether it be in-rack CDU, in-row CDU, or cooling tower for other servers, there's a video YouTube podcast I put out there called Green IT Data Centers that you'll see on SEC. I encourage you to view that entire podcast, which goes into a lot more detail on leak detection and how we're setting enforcement policy and how we've actually injected a payload within the Swagger URL or UAI that we provide, which is simulating actually a leak detection and showing you specifically servers that are either powered down at the server itself or killing power into the entire rack. This one is just really going to focus on just showing you the enforcement policy settings that you basically set, and then getting into detail about simple lifecycle management for an in-rack CDU. So in this particular screen, as I mentioned, we had launched the in-rack CDU. And at this point, you see on the side card here various other aspects of the lifecycle management for CDU that we'll drill down and take a look at in detail. So I want to draw your attention to the first thing here based on the carousel view where we actually expose the coolant return temperature and coolant supply temperature. So this is a real active liquid cooled rack where this B200 Blackwell chip is situated and providing a complete lifecycle management for that rack. And so this is the coolant return temperature real time that we're exposing within this liquid cooled rack, 25.32 degrees Celsius. And all our temperatures that we report within SuperCloud Composer are using the Celsius form factor, not the Fahrenheit form factor. And this is in line with the rest of the world, is basically on the metric system. So we have the coolant return temperature is 25.32, and then we also have the coolant supply temperature, as you can see, as 23.71. If you want to be able to update the firmware of the CDU, you simply click on this option. It will provide you with the ability to upgrade the firmware of the CDU. You can see here in the previous message when you came up is that it was indicating that you would be overwriting the flash of this BMC. It's sitting at 1500 as the current version. And here is the ability to select that CDU update from artifacts section, which is exposed within essentially this module here based on artifacts. So you can see here that you're able to look at the ability to upload the in-rack CDU firmware from this particular list here by using the upload function. And we provide all the other various different lifecycle management you can perform on either a switch or also on the system. But we'll not get into that detail. That will be a discussion we do at a later podcast. So the ability to upload the CDU firmware within the artifacts section and then come back into the cooling infrastructure for in-rack CDU at this point. And then what you can then do here is come back to this screen here and the firmware update showing you that the version we have here can be loaded and make a permanent flash and overwrite the current flash that is there. So also, if you want to go ahead and look at the logs associated with the CDU website, or also look at the CDU, this would be the ability to go directly into the BMC of the CDU. So the CDU has a BMC, and you can go in and take a look at information if you want. Just like we expose the ability for you to go into the BMC of a server or potentially one of Supermicro's switches. So that is from a standpoint of managing the CDU directly. We also expose physical asset information here that you can see on the right-hand side, indicating the location of where this CDU is present in this rack, and then the SKU and serial number and other pertinent information that you can obtain from the CDU as far as its physical assets are concerned. So we're going to drop down into the sensor reading section, which is really focused on lifecycle management. Shows you the uptime, the last time we received a poll with data from that BMC, which is a source of truth of the CDU. Operationally showing you operation mode, control unit, various different data that we're collecting from, or metadata we're collecting from the BMC itself and of the CDU, and then showing you a gauge meter of coolant return temperature and supply temperature and other important aspects or metadata we're collecting from the CDU itself, indicating coolant flow rate, dew point, heat load. All of these are available to you that were extracted from the source of truth being the CDU itself through its BMC interface through API calls. So we're going to move down into the analytics piece of this is really the sensor data that we're collecting, showing you the CDU status over a period of time. You can see here that there are delta points here that are over a period of time, and also showing you a health status associated with the pump, the valve, sensor, and humidity, all charted and points in time. And as I mentioned in earlier video podcast, the ability as a date picker that we bolted across the entire SuperCloud Composer platform, that you can actually do your historical trending. And then you can see here coolant monitor type data as well. These are the leak detection sensors that are outside of the CDU. So there are really two ways in which we report this information. There are two sensors in front of the CDU, which are sensor that you can put inside the rack and wrap around the supply that's coming in as far as water into the rack. So it's important to understand who has jurisdiction over the enforcement action. So there are two use cases around that. Is that if these leaks were ever detected at a rack level, SCC would have jurisdiction, report the action, and set the enforcement policy to shut down the entire rack itself based on the PDU through us building our universal agent across multiple PDUs. And the other use case or scenario is, what if there was a sensor leak associated with a cold plate? The BMC takes that action. It has jurisdiction about shutting down that server. And then we, as an SCC, report on that action. We don't set the enforcement action or policy. And we'll get into detail later of how you set this enforcement action in the event that there was a leak. And then we also see temperature information here showing you ambient temperature, facility water return temperature, coolant, facility water supply temperature. All of these are available and charted across the chart that we're showing, or the actual table. And you can see here by our charting here, by clicking on each one of these, you see that specifically things go into the foreground and also background when clicking on each one of these to be able to zero in on the type of metadata that's being charted from a graph or a chart itself. Okay, so that's from a standpoint of temperature. So we're going to drill down into now really the leak protection and how we do the server mapping associated with the servers. So we have a few liquid cooled servers inside this rack. Specifically, we're looking at the 172.24.169.23. If you recall, you remember, this is the actual Blackwell server for you that is liquid cooled and for managing monitored Blackwell Compute. You can see here that some of our leak detection sensors are basically disabled. If you wanted to enable those, you simply could change the global setting here under the admin. I'll show you that here. By clicking on the enforcement policy, you see it's disabled. You would basically enable it, save it as a global setting, and then coming back into the cooling infrastructure itself, you would see that that now is become available for you to be able to set that enforcement policy. So I'm not going to do too much of turning that on because these are running servers. Don't want to kind of mess with some of the other developers and other folks that are validating testing on this particular platform and other platforms within this rack. So one of the things I want to show you is, well, how would I set that enforcement policy? How would I set it from a PDU perspective of being able to control that? So I would simply click here. And again, you can click all of them depending on what your enforcement policy you want to set. Remember here that by default, the action is no action for shutdown enforcement policy. You have to go in and set your enforcement policy. So we give that the flexibility to DevOps administrators to make those decisions on what particular servers are going to participate in that enforcement policy. And we simply have a shutdown of the server so we can control just the server itself. by setting what we call the graceful shutdown, immediate shutdown, or no action. And the delay there you can set. So if we wanted to create a graceful shutdown, we can set in minutes what the delay time is. So you may ask, well, why would you want to do that, Kevin? If there was a leak, we'd want to do immediate shutdown and not do a graceful shutdown. And that really has to do with storage servers, right, that are simply being liquid cooled. Perhaps you want to make sure that those files are closed and that that server shuts down gracefully and would not impact any of the workloads or impact some corruption when the enforcement action was taking place. So the ability for you to set that, you set it to 4, then you save it, and then at that point, you would essentially tag that server to participate in a server shutdown in the event of a leak was basically detected. Again, SCC is controlling this because you detected a leak which was outside the server and at the rack level, and make those decisions on what servers want to participate in that enforcement policy shutdown. All right. So that's from a standpoint of the enforcement policy from a server perspective and SCC having control. So we're now going to go to the PDU console place of this, where this is where you actually associate an outlet by your mapping of what servers connected through some tag management that we have in place here to force a shutdown specifically at the PDU level. Now, I mentioned here in earlier videos that you can control the entire rack by shutting down the entire rack. If there was a leak was detected at the rack level, simply by clicking here and then allowing the enforcement action policy to be done with all servers that are going to participate in that. But in this use case, we're going to focus on Blackwell. So let's choose just the Blackwell one here, and that's this guy here. You see here that, again, it's SKU SYS422GA. It's a B200 accelerator inside this server for Blackwell Compute. And by clicking here on the PDU enforcement setting, now we can actually perform an action on that PDU to shut it down in the event of a leak to protect your capital investment within the rack. So again, individually shutting PDUs down per rack or shutting down the entire rack will all PDU outlets that are part of that rack would also be shut down if you decide to do so, and giving you the flexibility as DevOps administrator to do that. And again, we put the delay option in there again, as I mentioned, being able to make sure that we have an operation that you may want to perhaps delay the time before you actually perform the PDU shutdown, which would basically cut power to that PDU. So that's from a standpoint of providing you enforcement policy for Blackwell Compute in this use case. So moving on to the CDU piece of this, as I mentioned before, this is where you control individually each of those in-rack CDUs. Remember, there was the global setting that you turn on globally for the entire SCC platform. Now this is where you drill down individually and basically set your leak for those two sensors, which are outside of the server, part of the CDU itself, to control the leak detection shutdown. And moving to the operational mode here, we have an emergency stop condition where we make sure that the coolant supply temperature, if it reaches a certain value, and you can set invasive action to control the coolant flow rate depending on the temperature supply coming in and what's completely part of that closed loop that's associated with the CDU. And I also may indicate that there is a ratio between the coolant, such as the glycol, and the temperature. if there is a temperature value there where there's inconsistencies associated with the glycol and also the temperature, that indicates that potentially there's a leak somewhere else in the closed loop. Because we're monitoring the temperature, it's with not in the spec that we suggest, and that would result in essentially making sure we're not sending water directly over the cold plate itself. And when you send water over a very hot surface, the water tends to boil, right? And that's the purpose of having the coolant there, with the ratio between the coolant ratio and also the temperature. Okay, so that is associated with the in-rack CDU that we talked about. We talked about sensor data information, and we talked about enforcement policy, both from a PDU console perspective and also from a server perspective. We talked about the differences of who has jurisdiction of who's going to create the enforcement policy, whether that be the BMC individually controlling that, of initiating a shutdown condition, or essentially SCC setting the enforcement policy and immediately shutting down the server or cutting power to the entire rack. So that concludes this particular video that was focused on CDU management for in-rack CDU. Next time we'll talk about the in-row CDU. Thanks for joining. We'll see you next time.